Have a look at this question. Find resistance between A and B if resistivity is equal to 1 by 4x plus 5. For solving this question, we have to take the basic equation for finding resistance of a conductor. Resistance of a conductor is given by R is equal to rho L upon A. Rho is the resistivity of the conductor, L is the length of the conductor, and A is area of cross section, the shaded area here. Okay, but in this question, you are not permitted to use this equation because resistivity is not a constant. This equation is valid only when resistivity is a fixed value. But here it is given that resistivity is a function of position, or it depends on position. Or in simple terms, as you go from left end to right end, resistivity keeps changing. In such cases, we have to use the process of integration. So what are you going to do now? We will take a small element of length dx here. That element is having a very small length. It is called dx. And we will find the resistance of that tiny little segment. That resistance is written as dr. dr in the sense that it is very, very small, infinitesimally small. Okay? It is given by rho, which is given 1 by 4x plus 5 into the length of that element is dx divided by area is still there, area. So this is the small resistance for that small segment. So if you want to find the total resistance of the whole conductor, you should integrate between the limits 0 and 10. Why 0 and 10? Because the left and right ends are at 0 and 10 respectively. So I can find the total resistance by the process of integration. Integration of 1 by 4x plus 5 dx. A can be taken outside integration because A is a constant. As you can see, it is having uniform cross-sectional area. Area is the same everywhere, right? It's a uniform pipe. Okay. So 1 by A into, how do we do this integration? I can substitute for 4x plus 5 as u. If you differentiate it, it is 4 into dx, differentiation of constant is 0. On the right side, I have du. Differentiation of u is du. So I can get dx here, 4 goes to the right side, that makes it 1 by 4 into du. And if you take the reciprocal of this, 1 by 4x plus 5 should be equal to 1 by u. Why am I doing it? Because I need 1 over 4x plus 5 in terms of u. So finally, I have my modified equation, modified function for integration. For 1 by 4x plus 5, I have 1 by u into dx is 1 by 4 du. 4 can be taken outside. So I integrated. There is a standard formula for integration of 1 by u du. It is logarithm of u. So finally, I have 1 by 4a into logarithm of u is what? 4x plus 5. 4x plus 5. Now the limits are 0 and 10. So I can apply the limits now. You know how to apply the limits. First you put upper limit to the x value minus then the lower limit. So what am I going to get? This is 1 over 4a into logarithm of 4 into upper limit is 10. So 4 into 10, 40. 40 plus 5 is 45. So logarithm of 45 minus, now comes the lower limit. 4 into 0 plus 5. It is 5. So logarithm of 5. Finally, I can use a logarithmic identity which I learned in lower classes. Logarithm of a minus logarithm of b can be written as logarithm of a by b. Now by that equation, this can be modified as resistance is equal to 1 upon 4a. Logarithm of 45 minus logarithm of 5 is logarithm of 45 by 5. which is logarithm of 9. That will be the final answer.